Good evening, everyone. Uh, Today we are going to start our Python and Data Analytics Internship session 37. So today's topic that we are going to cover will be focused on introduction to clustering. Basically, we will learn about what is clustering and what is k-means clustering. Okay, so you have gone through that we have basically two machine learning approaches like supervised learning and unsupervised learning. So in supervised learning you have seen linear regression and other. So in we are as a part of unsupervised learning, today we are going to see what is k-means clustering and what is clustering. So the learning objectives for today's session will be as follows. Like, we will see what clustering means in simple terms. Then we will understand the idea of unsupervised learning again. And then we will see about describe how the k-means clustering algorithm works step by step. We will see that also. Choose the number of clusters using elbow method, implement k-means clustering in Python, and then we will move to interpret clustering results visually. So let's start. What is clustering? The very first question which comes into our mind is that what really clustering means. Okay, so we have seen that in unsupervised learning and supervised learning, we have two basic differences. Like in supervised learning, we already know the labels and we already know the groups. Okay, like we have the data, we work upon the labels, and that output can be predicted. But in clustering, what happens is that we don't have any kind of labels. We create groups based upon the data points. Groups are similar to clusters. Okay, so they both are synonyms to each other. So like you have a variety of data points with you. Like in data set, there are no labels defined particularly. So what we do in unsupervised learning is that we try to find out the patterns that are hidden in that jumbled data. Okay, that you cannot understand through naked eye. So you what you need to do is that you need to use an algorithm to cluster all those jumbled data points into similar points of clusters. Like the points that are very close to each other, that resembles the similar pattern, should be grouped in one group, in one cluster. Other data points that are similar to each other will be grouped into other clusters, into other group. Okay, so we are separating the data based upon the similarities of the patterns that are hidden inside that data, and then based upon those patterns and similarities or properties, we are grouping them separately based upon their properties. Okay, for example, you can consider as a simple example as like that. All those students who are having blonde hairs should be grouped in one group. All students having black hair should be grouped in another group, if we want to basically separate them based upon the color of their hair. Similar things can be applied also. Like someone belonging to all the students belonging to Delhi. Suppose you met in a fair, for example, a book fair. Now you want to categorize the students. So all those students who are based in Delhi should be grouped in another group. All those students who are from basically Mumbai should be grouped in another group, and all those students who are from Chennai should be grouped in another group, if we want to group them different separately. So what happens as a result of grouping is that Delhi students might be interested in Hindi literature, okay, or books written in Hindi, because they can easily read it and understand it. The students from Tamil Nadu basically might want to read the same book, but their preferred language can be different. Like if they are from Tamil Nadu, they are fluent in Tamil. So we can group them in another group so that we can provide them the copies of Tamil literature. Okay. Uh, so this is how grouping helps in basically sorting out things. and basically predicting what the particular student might need. We don't know for sure whether he will be needing this only. It might be happen that someone wants to read Hindi books from Tamil Nadu, or from New Delhi wants to read Tamil books in Tamil. So, but we are certain that okay, since they belong to different places, although we are from same country, so their interest might be different, their interest might be different, so we can focus upon that only instead of providing all things together to them at once. What we can do is that we can group them together and then provide different things to them according to their interest. So clustering is a technique used to group similar data points together, as we have discussed now. Okay. So this is how clustering basically looks like, or this is how what it means. So key points that we need to basically remember in clustering are that data points in the same cluster are more similar to each other. As I told you, the group belonging to Delhi will be speaking in their mother language as Hindi. There might be a thing that someone who has knowledge of South Indian languages is also present in that group also. Okay, but we know that okay, based upon our assumptions, because we are basically grouping them together based upon the location from which they belong. So they might have similarity and they are very similar to each other. So this is what we want to tell you. Okay. Data points in the same cluster are more similar to each other. Second thing is that data points in different clusters are less similar. Okay. Now, uh, for example, as we have seen this example only, it's a common logic. Okay. When a person belonging to a same group contains similar properties to all the persons that belong to that particular group, and there is different group, so different means there will be less similarities between both the groups. If there are less similarities between both the groups, then the persons belonging to those particular groups will also have less similarities to each other. Okay, so data points in different clusters are less similar. This is what this point basically wants to tell us. No predefined labels are required. As we have told you that in unsupervised learning, we don't need to basically have the labels. We are grouping them together based upon the properties, based upon the things that are similar to each other to those data points. Real world examples can be, wait a sec. So real world examples, if we see that in real world, what it actually means, like grouping customers by their buying behavior. Okay. Then segmenting students by performance patterns, like average students, below average students, or uh, top, basically toppers or top students. Okay. Grouping news articles by topic, like some articles will be based upon geopolitics, some articles will be based upon economics, some articles might be based upon local news, and some article might be based upon defense or some other topics. So grouping news articles by topic is also an example of this clustering only. Anything that can be grouped basically comes under clustering. Clustering helps us understand structure in data. Okay, we are solely focused upon what patterns are hidden inside that particular data. We are focused what this data wants to tell us, because till the data is jumbled, okay, it is mixing up with all the data points. You cannot find anything from that data. Once that data is grouped based upon the similarities in the data points, then those groups can be studied to derive further insights from them. Okay. So let's see what unsupervised learning was. It is basically a brief overview so that You might not get confused here. So unsupervised learning works with unlabeled data, as I told you earlier. That means no correct answers are provided. The algorithm explores the patterns. Pattern is a very important word. Okay, here we are basically focusing on finding patterns inside the data. Our main goal is this only. So common unsupervised tasks might include as follows, like clustering, grouping similar data, dimensionality reductions, simplifying data, anomaly detection, finding unusual behavior in the data. K-means is one of the most widely used unsupervised algorithms. Okay, so it is an algorithm which is developed for you. You need to use this in your code. Okay, and then what it does is it basically separates the data points present in your data set based upon the similarity of those data points and group the similar data points in one group. Okay, here K equal to how many groups you want to divide your data. This has to be this has to be decided before implementing this clustering algorithm. Okay, suppose you want to create two clusters only, so only two clusters will be created. If you want to create three clusters only, then k equal to 3, it means k 3 what we call groups will be created, sorry. Okay, so k simply means the number of groups we want. It depends upon you, and this should be decided before running the algorithm. So now in K means, what means actually means. Okay. So means refer to the average position of a group. What will be the average position of that group in a chart that we will see. Okay. Now remember the word centroid. The average point is called a centroid. Okay. Centroid is nothing, basically a center of cluster. Suppose you are having a group, na? So the center of that particular group is centroid. Around that centroid, all your data points will lie. Consider it as an example, like in a school, students are playing in a playground. Okay, so we have placed three flags in the field, and each student goes to the nearest flag. Okay, now move each flag to the center of its students, basically. Okay, so the flag will be at the center, and students will surround that flag. So this is basically like the flag is like a centroid there, and students are gathering around that centroid. Okay, so we have to choose k, that is number of clusters. Then k is the place k centroids randomly. The value of k defines the value of centroids. If k is equal to 3, then centroids will be 3, because three groups have three centers. Okay, so K means improves group steps by step, basically. If we give K means customer age, suppose for example, and then what we say, suppose how much a customer is spending based upon their age, it groups customer with similar behavior. Here, no labels are required, no answers are given. We are basically finding the patterns in the data. Let's move to next slide. What is K-means clustering that I told you earlier? Like K-means clustering is an algorithm that divides the data into K distinct clusters. K is equal to the number of clusters that are going to be created. Each cluster is represented by a centroid. Every group, every cluster will have a center point that we called as a centroid. Mean refers to the average position of points in a cluster. And that average position is calculated from the center of that, from the centroid. When K means works best, let's see when we should use it. When data is numerical and continuous, okay, and clusters are roughly circular, means they can be spherical, but they are basically in circular form. Number of clusters K is known or estimated. It depends upon you. K means is simple, fast, and widely used in industry. It is very, very useful when it comes to a clustering. Okay. In unsupervised learning, K means clustering helps a lot when you want to identify the patterns present in the data, in a jumbled data that you have with you. Okay. How the K means algorithm really works. So let's see the step-by-step process. Choose the number of clusters first before implementing the algorithm. Then randomly place K centroids. Okay. K centroids are equal to number of clusters that you have. Assign each data point to the nearest centroid. Okay. Then the data point will lie to the nearest centroid having the similar properties to that centroid basically. Recalculate centroid based on assignments. Then the recalculation happens whether it is placed correctly or not. If not, then the process repeats itself until it is placed at the very right place. Repeat steps 3, 4 until centroids stop changing. You need not to do yourself. It is done by the algorithm itself. Okay. So first, randomly, those data points will lie to any nearest centroid that they have. Then they calculate their distance, their average basically. Then it finds that okay, this is not the right place. Then it is placed to another centroid, then to another centroid until it finds its right position. Once the data point finds its right position, then it stops changing. And when all those basically until the centroids will then stop changing, and then our algorithm has basically grouped all those things together perfectly. So output will be look like cluster label for each data point, final centroid positions. Okay. The algorithm improves cluster iteratively. The elbow method. Choosing the right number of cluster is very, very important. Okay. So like we have elbow method for that. We try different, you should try like once you are trying k equal to 2. In another run, you should try k equal to 3. In another run, you can try k equal to 4. Then calculate WCSS. What it means? Within cluster sum of squares. So it is a mathematical term basically. After it is calculated, it is, I'm just giving you an overview of elbow method. You don't need to basically implement this right now because it is slightly confusing here. But I'm telling that there might be a question in your mind that how do we know what is the exact number of k that we want? So that can be calculated through elbow method. Okay. So elbow method then point where the reduction in WCSS is slows down indicates number of optimal number of clusters. When you start seeing that the value of WCSS is slowing down, that is a reduction, okay, where the reduction in WCSS value slows down, it means that is the perfect number of K that you should use. But for now, we will be basically trying hit and trial method. We will be guessing what amount of clusters you want. Okay. So before going to real world use cases, let's see something through coding. So what we are going to do is like we are importing pandas, importing matplotlib in order to see it visually. Then from sklearn cluster import k means we are importing this algorithm that is a part of scikit-learn library that we have installed. Okay. Then these are the standard scaler. I have told you in earlier session that we use it in order to basically reduce the difference between the values so that one value should not dominate another value. Okay. So that the graph is plotted fairly. So first, what we will be doing is that we will be reading our data set. Okay, I haven't put the data set in yet. So we will be dragging this. Wait. Just give me a second. I don't know why it is happening. Okay, so we have our data set with us. Customer ID, age, annual income, and spending score. Spending score basically means how much that customer is spending. Okay, so we are going to import read this data set. So as we have done earlier, read CSV pd dot CSV, then the name of our data set. Okay, df dot head. So this is how our data set looks like. Now, what we will be doing, we will be selecting features for cluster. Feature basically means which column we want to use in our clustering, like which on which column we are doing our clustering based upon which column. So we will be using annual income. That is this. Then we will be using it with spending score. Okay, let's run it. Now, first we are going to visualize the data before clustering. Let's see how our data looks like. So plt dot scatter on x-axis, we will be taking annual income, and one we will be going to take spending score. Plt dot x label plt dot y label then plt dot title, then plt dot show. This is not defined. Okay, we have used small x here. So let's make it capital, run it again, then run it again. So now, for now, this is how our data looks like. Okay, if I zoom it out a bit, like you can see, it is basically present everywhere. It's scattered everywhere. You don't, every data point is basically, there is no pattern that you can identify from your naked eye, or no, there is nothing that you can drive from this data. It is randomly placed everywhere. It is scattered everywhere. Now, what we are going to do is that we will be going to group those data points having similar properties in one group, and those data points having different properties in another group. How it helps us? Basically, it helps us by grouping together all those data points that have similar properties, so that we can analyze the behavior of this data, or the insight that this data wants to show us. But before that, we need to scale down it using standard scaler, so that none of the value can dominate each other. So x scale equal to scalar dot fit transform, and then in it we are passing x. So let's run this. So it is scaled down now. Now we will apply k means clustering. For now, we are going to choose k equal to 3. So k means equal to k means, and here we are n clusters equal to 3. So we have defined here that clusters are equal to 3. M will be capital in k means. Okay, we have defined the number of k, that is n clusters equal to 3. There will be 3 clusters, and random state is equal to, let's suppose, 42. You can define anything here. Now for clusters equal to k means dot fit predict x underscore scaled one. Okay. Now df cluster square brackets will come here, since we are using okay, df equal to clusters. Then we will print those, print df dot head. Let's see how they look like. Okay, we are getting an error, keys in it. Let me see why we are getting this error. It's a random state. Acha, random spelling mistake is here. So it is running and then will provide us two things like it has placed customer ID 1 in cluster 1, customer ID 2 in cluster 2, customer ID 3 in cluster 0, customer ID 4 in cluster 1, customer ID 5 in cluster 2. Similarly, it has basically placed all the values. So we have used k-means here. Now k-means algorithm has created the groups that is 0, 1, 2. These are all three groups. And in these particular groups, all the values that are similar to each other are placed to that are placed in similar group. Now, if you want to see it visually, we can see it like we will use plt dot scatter. Again, you have seen in the earlier visual that how uh, the data points were spread all over the graph basically. Now we will use the same thing here also, and let's see what changes have occurred by using k-means algorithm. Now we will use plt dot x label. Plt dot y label. Pending score. Plt dot title. Title will give customer segment after using K. Then we will use plt dot show. Okay. So now let's see in on graph how the visualization look like. Okay. Now you can see that all the data points are grouped based upon different colors. Different colors equal to different clusters. So model grouped customers automatically. Earlier we were not knowing how or which group these data points basically belongs, but in this you can easily see that this is one group, this is one group, and this is one group. It is having basically low income and low spending. It is this point is having low income, high spending group. Okay, they are spending more and they are spending less, even though their income are annual income are basically more. And if you want to see the centroids, now let's use that thing also like centroids equal to we will use scalar dot inverse transform k means dot cluster. Okay, then underscore centers. Okay, तो centers के बाद underscore. Now we will plot this on the graph like plt dot scatter indentation errors plt dot scatters. Similar thing again. Let's copy it from the above. This is basically similar to that. So let's paste it here. Okay. Now, the thing that we are going to add in here is plt dot scatter. Then we will be using centroids group 0, centroids group 1, centroids, sorry, 0, 1. And then we will be using color equal to red. Okay, color equal to red. What we can use next is marker equal to, let's say, x is equal to red and centroids. After that, we will use tlt dot x label and will come plt dot y label pending score plt dot title clusters with centroids plt dot stop. Okay, the error has occurred. X and y must be the same size. Okay, here we will have comma and here we will have comma. Let's run it again. Okay, now it is perfectly. So here are our centroids. As you can see, this X represents our centroid. We have used a marker for it and color as red. So for this group, that is purple group, this is the centroid. For this blue group, this is the centroid. And for this yellow group, this is the centroid. Okay. So red X mark, the red X marks basically shows the center of each group. Okay. So this is what we were discussing about centroids. Also, we can do one more thing, like we can use df dot group by cluster, then having annual income then comma spending score. Now you can see it here. Okay, we have group basically calculated the spending score for the each group. Like average income for group 0 is this, spending score this, group 1 yeah, this, spending score this. So this is how we can see. Here we can easily see that group 1, okay, is basically having high spending score means these are the people who like to spend a lot. They spend a lot of money. And the least amount of spending is coming from group number two. And zero comes between both the groups. Okay. So this is indexing basically 0, 1, 2. If we see group number one is equal will be equal to 1 or 0, group 2 will be equal to 1, group 3 will be equal to 2. So we can interpret clusters after clustering. Okay. Model basically is grouping all those things together. So cluster 0, if we see, is having high income. Okay. But sorry, cluster 1 is having this one, middle one. We are seeing through the index now. So it is having basically high income and high spending. Cluster 0 is having medium income. No, no, high income is from this one. Okay. One stands under double. Okay. So you can see they are having high income but less spending. They are having basically medium income but high spending. They are having low income but medium spending. So this is how we can interpret those data points now from this data. This is how clustering usually works. So what are the real world use cases of clustering in business applications? We can use it for customer segmentation, targeted marketing. If we want to target a group of people, as we know, as we have seen in our code, in example, like there is a group having high amount of income and they like to spend a lot also. So we can target those people. The similar things can happen in fraud detection, product recommendation. Technical applications are image compression, document clustering, pattern recognition, and data exploration. These are all real world use cases. Cluster is used whenever we want to understand groups in data. Okay, remember that thing. So we have seen Python implementation. I have shown you that in the example in VS Code. This is the same kind of example. You can refer to it for your own understanding. So for the assignment, you have to load a data set. Either you can load iris data set or any other custom csv or mol customers data. Select two numerical features as we have selected in our live example in the VS Code. Apply k means with k equal to 3. For now you are going to use k equal to 3. Don't bother about elbow method. Visualize clusters and print cluster centroids. Okay, and write a short interpretation that you are able to derive from all those groups, like we have seen in the example, live example in VS Code. Okay. So for any support or for any help, you can contact us here. And thank you for joining today's session.